All right, so I'm going to go back over osmosis in terms of how things move. Okay, so the first thing I want you to remember is that, osmosis is only water. Okay, and it always moves from an area of high concentration to an area of low concentration. So that's why if you look, water is going through this membrane because I have a high concentration of water. That's all the blue dots, and a low concentration. So some terms that you need to be familiar with. Since this has a high concentration of water, this would make it hypotonic. All right. Since this has a low concentration of water, this would make it hypertonic. Now, when you're looking at osmosis, remember, high concentration to low concentration of water. So wouldn't it be easy to say, or safe to say, that I'm going to go from a hypotonic solution into a hypertonic solution? All right. That's how water moves. It is passive transport. We don't need any energy to do so. Okay, let's look at our next picture. So our next picture, I've got 3 beakers, and I've got different pieces of, let's just call it potato, inside of the beakers. So right now, this beaker has 10% salt. This has 2% salt. This has 30% salt. Look, just to make it easy on you, go ahead and write the amount of water, because remember that always equals to 100%. So this would be 90% water. This would be 98. Let me draw my percent so y'all don't think they're crazy. 98% water. And this would be 70% water. Okay? All right, let's look at inside this potato core. So if I have 10% salt, that means I'm going to have 90% water, right? If I have 10% salt. So all of these are the same, okay? 90% water. All right. So what I want you to look at, once again, osmosis goes from high to low. So look at your water concentration. Here you've got 90% water and 90% water. Does water move? Yes, because water is always moving. The difference is water is going to go in both directions, and it's going to be an equal amount because it's at equilibrium. And that's what the goal of this is, to get to equilibrium. Okay, where both sides on that membrane, both sides are the same. Okay, so if I look at this one, I've got 98% water and 90% water in. So once again, look right here, high to low. So water is going to come into the cell. So this is considered to be a hypotonic solution. This right here is hyper, because that's what's drawing the water in. And so your potato is going to swell, okay, because it's going to take in some of that water. All right, let's look at our third beaker. Our third beaker, we have 70% water outside, and we've got 90% inside. So we can label this solution as hyper because notice that there's more water in the potato than the concentration that is in the outside. So remember, you always go from high to low, or hypo to hyper. So that means this is going to go, I'm going to use a different pen here. This is going to go out of my cell. Okay, so that potato is going to shrink. All right. So I'm going to put in some numbers here. This is kind of like the little diagrams that I gave you today. Let's say that I have 5% salt. And in this one, I've got 0% salt. Okay. And if I look, and let's say in my beaker, I have, let's say that I've got a 1% salt concentration, and over here I've got a 10% salt concentration. So look at where the most water is. If I've got 5%, that's really 95% water. If I've got 1%, that's 99% water. So my higher water is going to be right here. So I'm going to move, water's going to move into my cell because this is considered a hypotonic solution. This is hyper, and I'm going from high to low. All right, if I look at this one, if I've got 0% salt, that means I've got 100% water. You might see this called DH2O, which is distilled water. And I've got a 10% salt concentration. So that means I've got 90% water. So when you're looking at this, obviously 100 is bigger. So water is going to be pulled out of that dialysis tube. And so this is considered hypo, whereas the solution itself is hyper. And that's what's going to cause. So this one is going to shrink and this one is going to swell. Okay. All right, one more picture and then I'm going to stop. So on your homework tonight, you had, or if you're looking at any kind of problem that has, this is like it's called an osmosis tube. So it's a U-shaped tube and it's normally filled with water. Right here, you have a selectively permeable membrane, meaning that it's only going to allow certain things to move across that membrane. In this case, water is being selected for. Okay, so if I've got 12% salt here and I've got 3% salt here, that means I've got 88%, right? My math may be off. Nope, that's good. 88% water. And over here, I've got 97. Okay, so when you're looking at this, where's the bigger amount? On this side. So if I asked you the question, which side of the tube will the water level rise? Okay, so if you've got, this is your higher concentration of water, meaning that it's hypotonic. This is your lower concentration of water, meaning that it's hypertonic. Water is going to flow to this side. And so what you're going to see is, let's say that this is where it was to begin with. You're going to start to see as water moves through this membrane, the amount of water goes up on this side because it's trying to reach, here's my key word, equilibrium. Okay, I hope this has helped kind of solidify what we were talking about in class today.